Hello everyone, welcome back to my channel, The Learning Path. This is Dr. Bimina, Associate Professor and Research Supervisor from Petition College of Arts and Science, Adayar, Chennai. In this video, I'm going to teach you one of the modern method in capital budgeting techniques, net present value, which is otherwise called it as discounted cash flow method. Whenever we are going to calculate the net present value in as usual way, we need to work out what is the annual cash inflow. So the content and format I said in the previous two videos are common to calculate the annual cash inflows, which is otherwise called as profits after tax and before depreciation. So that is the usual format. Whenever the annual cash inflows is not given in the question, we need to work out like that. So once you calculate the annual cash inflows, then we'll make a move on to calculate the net present value of the each and every year cash inflows for the future period. Check. This slide will explains you how to calculate the net present value. So look at the format. Usually in the problem, they may give you what is the net present value either at a 15% or a 10% or 20%. So we are going to consider the net present value is going to recognize the discounting value of the money for each and every year. The discounting percent can be differ based on the problems. It can be sometimes ask you to calculate the present value at 10% or 15% or 20%. Based on the percentage, we need to work out the present value of a rupee for each and every year cash inflows for the future period. So in case the values were not given in the question, let me discuss how to calculate those values. In case the present value at 10% means for the first year, 1 into 100 divided by 110. That is 100 plus 10 because 10% is the present value. So I will get the value as 0.909. In case of the second year means take the same value for the second year multiplied by 100, the whole divided by 110 means I'll get the second year value. After getting the second year value, multiply the second year value with 100 by 110, I'll get the third year value. Likewise, I will calculate for fourth year and fifth year. In case the values, present values at 10% or 15% or 20% were not given, this is the way how to work out those values. Once the values were calculated, whatever percentage discount rate is given, then multiply the present value at 10% values with the respective year cash inflows, then I'll able to calculate what is the present value of the cash inflows of the future periods. Likewise, next first year I'm getting this cash inflow means what is the present value? Next second year I'm getting this much of cash in. What is the present value of the second year cash inflow? So likewise, I can able to multiply the cash inflows of future with the present value, either for first year or second year or third year or fourth year or fifth year. So these values must be multiplied with the respective cash inflows to calculate the present value. So once you got the net present value, this net present value has to compare with your investment, has to compare with your investment. If the net present value is more means than your investment value, then accept the project. If the net present value is lesser than your investment means, then reject the project. So let me have one problem model to have more understanding on net present value. Project Z initially cost rupees 25,000. It generates the following cash flows. So we have the cash flows for first year, second year, third year, fourth year, and fifth year, and the table values were given. The present value at of rupee 1 at 10% were given. So how to take a decision whether to accept the project or going to reject the project. So when the present value of rupee at 10% is given, it's very easy to work out how to calculate the net present value. Just check out this. That is cash inflows and present value of rupee 1 at 10% already given the question. I just return against each and every cash inflows, and cash inflows 9,000 into point 0 or 0.909, I'll get 8,189. Likewise 8,000 into 0.826, I'll get 6,608. 7,000 into 751, I'll get 5,257. 6,000 into 0.683, I get 4,090. Likewise, I multiply the cash inflows of each and every year with the present value of rupee 1 at 10%. I'll get the present value in rupees. So the total present value I'm getting 27,249. But the investment, what is the investment value is given the problem. The investment value is how much? 25,000. So this 25,000 investment has to be compared with my total net present value. So what is the present value? 27,249, which is more than my investment. So I'm getting positive answer. That is, my present value is more than my investment made. So I can accept the project. The project result is preferable because of the present value of NPV of rupees 2,249, which is I'm getting in a positive way, which is more than my, that is total present value is more than my investment. So this is the way how you can understand how to calculate the net present value. Let me check one more problem. Look at this. We have four investments, PQRS. The initial outlays were given, and then first year, second year, third year, in cash inflows were given. Rank the investment. The question is rank the investment, finding the net present value using the discount rate at of 10%, present value of 1 rupee due at the end of the year. So the present value of rupee 1 due at the end of each year is given the problem. So look at the solution. So I just put the title calculation of net present value. The investment cost is 20,000 for all the type of investment. Okay. So I mentioned the years in the first column, NPV values, and I add four columns for investment P, Q, R, and S. And I return the respective cash inflows for the respective years for each and every investment. For each and every investment, I return the cash inflows, and then I multiply the cash inflows of each investment with the net present value at 10%. Like for example, 20,000 into 0.909, I'll get 18,180. Again, I'm repeating, 20,000 into 0.909, I'll get 18,180. Likewise, 10,000 into 0.909, I'll get 9,090. Likewise, 2,000 into 0.909, I'll get 1,818. 20,000 into 0.909, I'll get 18,180. Likewise, I need to complete for the second years and third years. If it is given nil means no issues, put it as a nil. Okay. Then look at that. I just calculate the total present value for investment P, 18,180, for Q, 24,860, and R, that is that summation of 1,818, 8,260, 22,530, I'll get 32,608. Likewise, I'll add all these 3 years. For investment A's, I'm getting 21,334. Just as usual way, like a previous problem, I compare the investment for all the investment kind. It is 20,000 only. So just check out the values. For investment P, I'm getting a negative value. That means my total present value is lesser than my investment. That is why my net present value is in the negative manner. Investment Q, I'm getting 4,860 in a positive way. That is, my total present value is more than my investment cost. And then in investment R, 32,608, is the total present value, but the investment value is only 20,000. So I'm getting the NPV as 12,608. Likewise, I calculated for investment date. So as per the net present value, I will ranking the investment. The first ranking will be given for investment R because the NPV is more, and investment Q, the NPV is 4,860, then I can give second ranking. And investment is 1,334, then it will get third ranking. But investment P minus 1,820, that's why it has got fourth ranking. So my conclusion is investment R is preferable because of its highest and present value. So this is a way we can have an understanding how to calculate the net present value of all our investment proposals, then how we will take a wise decision to choose our investment when we have options. Thanks for watching my video. See you again next video. Until then, bye-bye.